Alright, so this is LED flashlight hacking part 3. As you can see, part 2 is uploading. So while we wait for that, we're going to make part 3. Part 2 we showed you some of the cheap Dollar Tree flashlights that we've done. And again, the purpose really is to just take cheap flashlights and make them more decent. Like these $5 little LED work light I got from Harbor Freight. With the Cree LEDs in it, the LEDs will last for years and years versus Chinese ones that they have in there. This generic probably won't last that long. I've been told by other YouTube user that's done some testing with a light meter that their output fades pretty quickly. So the Cree LEDs are not going to fade, they're going to last a lot longer. So in this video I want to look at some other lights that I've made and some other lights that I've hacked, like this Eveready LED lantern that we saw in part 1. Now I've tried the 4.8mm wide angle LEDs and they're too short. They're shorter than the original LEDs and they just didn't work. This one's got the 15-degree LEDs in it. I'll give you a shot of this with the lights out here in a minute. Still not as bright as the original LEDs, which are actually pretty decent quality. You know, this light at Home Depot cost me $5 with the 6-volt battery that's in it, and it says it's rated for 65 hours. I haven't tested that yet. Battery life testing is in another video. And we showed you the Stanley 5-watt LED flashlight, or maybe 3. I think it's 3. Either way. I tried out this flashlight from the Dollar Tree also. All I can say about it is it turns on. Really wouldn't waste your dollar on it. These are good little flashlights to have. They work on 3 AAAs, so they're going to last for a while. And it's got a decent amount of light output. You can do stuff with these flashlights. Like I mentioned before, great. Get to the kids trick-or-treating or just in general, camping. If you lose them, you're only out $1. Kids break them, you're only out $1. Versus if you handed your kids the Maglite XL50, they would be able to see everything. So that's 105 lumens, but if they lost it, you'd be out $30. You're not going to break it. You could drive a truck over that flashlight. I've done it. And we also showed you the little LED puck lights here. $5 from, or $3 I think actually, from Harbor Freight. I've tried puck lights from like the Dollar Tree and stuff like that. These for the money seem to be the best built. I know you can buy better ones at like Home Depot, but that defeats the purpose of cheap. These put out a decent amount of light. Double stick tape. And then my favorites were really these. This I think was the neatest find I found. They put out a decent amount of light. This is the factory one. They're easy to hack. Everything screws apart. Circuit board comes out nice and easy. So I got a couple of these. I'm gonna do some with blue LEDs, UV LEDs, red LEDs, just for different stuff. So I wanted to show you some of the other stuff I'm working on here. This is a 150 watt quartz halogen floodlight you can get at Home Depot. This one mounts to a wall box. I found that it works on a table just fine. What I've done is I took out the quartz halogen bulb and put in this 54 LED array with the P4 type Superflux LEDs. Now these are just generic kind of Chinese ones. I'm going to make one with the Cree P4 LEDs that are about 34 cents a piece. I paid $15 for 300 of these LEDs. They're pretty bright. They do the job. And I got these circuit boards. Let me switch into macro here. I got these circuit boards from the UK. Now they're designed to be RGB, like color changing effects lights. You can see that's the website there, rgbfx.co.uk. And they have separate inputs, separate traces for each of the three colors. And then the board is broken out. And then you have individual resistors. Sorry if you're getting motion sickness there. For each of the three colors. Obviously you can do them all in white or all in any one color. All you got to do is tie these three solder pads back here together, and then that's a common anode, positive. So these are a couple bucks each. I haven't found them anywhere but the UK, and they actually advertise that they fit right into the 150 watt floodlight case. So figured I'd give them a shot, and they work good. They're bright. I also built this one, which is just a little quartz halogen work light. It's nice because it's got a switch, and I put that same circuit board in. But what I did is this other one these run off 12 volts. This one I put a wall wart behind there. Just took out the quartz halogen bulb, soldered a wire to the wall wart, heat shrunk it, tubing, and this works off 110 volts. I lost a screw that goes to here so it doesn't stay closed, but you can see that that is a bright light. I don't know how many lumens it puts out, but it's bright. Now, it's not as bright, obviously, as the 150 watt quartz halogen, but the whole idea is cheap, and the advantage to the LED, in this case, since we're plugging it into the wall, obviously it's going to use less power from your home power circuit there, your 110 circuit, but also if you're running it off an inverter, like say in a car or a generator, you can have a lot less load. Plus, if you use it in a small enclosed space, or like inside a car or something like that, it doesn't generate any heat at all. This doesn't even get warm to the touch. The other advantage, obviously, is that you won't ever have to change these bulbs out. These bulbs will last for quite a while. But you can see this really puts off a decent amount of light. I mean, this isn't, you know, scribbling for keys in the dark light. This is, I could read by this light. I could do a brake job by this light easily. It really lights stuff up. So that works good. And we'll show you this other one here. This is the other little one I built here that works off 12 volts. Let me just grab 12 volts from over here. I know I'm a horrible videographer, but alright. So there you go. That's running on 12 volts. the wall wart or wall power adapter that we put in the other one was 12 volt 500 milliamp adapter. It was able to run that whole thing 500 milliamps. It could probably run on an amp. I don't know if it would get any brighter. It's got current limiting resistors for each LED, but this one's just running off a 12 volt power supply, computer power supply. Now we got over here. Yeah, I can't see, it's buried in junk. But anyway, I've run this light off of a sealed lead acid battery, the type you get in a UPS, a battery backup. I've run this light for 3 days straight with no dimming from a small 10 amp hour battery. Off of a car battery or something like that, this light would last days, weeks. Does not draw that much power. It's got 54 LEDs. Each LED is only drawing 50 milliamps. So, actually with this resistor that I've got in there, it's probably only drawing 35. So that's, and it's wide angled too. And it's probably 120 degrees. Now if I move the board up closer to the glass, probably get a little bit wider. But that's what we did for this one. Let me show you some other stuff I got going on. This is this little LED desk lamp that we did in another video. But instead of the wide angles, I did this with the Cree 503Cs, 15 degree ones. And as a desk lamp, it only works a very narrow angle, so I use it for the solder station here. It gives me good light output for that. Real quickly, I wanted to show you some of the other projects I'm working on. I got these printed circuit boards from a company in China, of course, called AmpleBiz. I think the 6 of them cost me less than $10. I also got these square circuit boards. Those round ones are 108 LEDs. These are 48 LEDs. And these take a current limiting resistor. The round ones don't. They run right off 12 volts. This is a board I built with, let me switch to macro here, the Cree wide angle LEDs. And you can see it's got no current limiting resistors. With this many LEDs series paralleled, it'll run direct off 12 volts as long as you're not jamming it full of current. 500 milliamp wall adapter would work fine. If not, you can run a 1 watt low resistance, say 1 ohm to 10 ohm. Sorry, I'm probably not in focus here. I'm trying to hook this up. Resistor. There we go. And it'll run just fine. Now this is with the wide angle LEDs. And you can see it, I mean, it lights up the room. These aren't designed to replace a, quartz halogen floodlight or anything like that, but if you had a power outage, oops, I live in a hurricane area, you could light up a tent or anything with that running on a battery. So stay tuned. In future videos I'm going to talk about battery life and rechargeable batteries, and showing you the real efficiency of LEDs and why they're so much better. So stay tuned, we got more to come.